What's good, people? Adversile here with the fifth episode of the scripting series. Welcome back, y'all. How's your day been? Hope it's been good. I've decided that for this recap, I'm just gonna do the quiz from the last video because I feel if I did the quiz and the recap, that would just take too much time, right? And then of course today I'm gonna talk about if statements. Or sorry, I'll just call it conditional statements. And that's pretty much what we're going to talk about that's pretty much what we're going to talk about for today. So it might be a little bit shorter of an episode. But yeah, we're just going to dive straight into the quiz. So I'm going to open up a script and you can go back to that video and just read along. So the first question is, so I'm going to create a comment. So a comment is when you put two hyphens or two dashes, and then it creates a comment line. So ordinarily, if I did blah, 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 it'd throw an error because this is assuming that this is actually part of the script. And in this case, it'd be improper syntax. But if I put two hyphens, it creates a comment, which means you can type text without putting it in a string or whatever. And I can just say, hello, this is a comment. And comments are just useful for commenting on your code. So leaving notes for yourself, like maybe something you coded yesterday and you want to come back to it today. It's just good for organizing your code and making sure that you can break down every piece of code that you wrote. I don't recommend writing comments too much though, just for places that you need them. And of course, the way that you write multi-line comments is two double square brackets and then click enter twice. And it should look like this, and then you can write multiple lines if you require that. Either way, question one was, what is a function? Well, a function is a data type that allows you to only run a specific block of code if you first call the name of the function. So let's just do an example. So local function. So we define that it's a function. It's a local function, which means its scope is restricted to the block that it's in. But in this case, it doesn't matter because it's not in a block. But it's always good. It's always best practice to include local when defining variables, functions. Then we name the function. And this generally has to do with what we want to do with the function. So let's say print stuff. Now, there's something unique about functions which allows us to store temporary variables called parameters. And let's say these parameters are, let's say it's message, sorry. And we're going to print message. And you could probably already figure it out. When we call the function, this parameter, we're going to refill with our argument. And that's going to print whatever this parameter is, and then it's going to replace that message, or that parameter with our argument when it goes through the function. So when we call it print stuff, and we include the message, right, because we're printing whatever the message is. Basically, the parameter is the temporary variable that only applies to the function. You can only use this parameter inside the function. And then we replace it with our argument, which is what we want the parameter to equal, the value of the parameter. And since we're printing something, let's just say a string, for instance, and we'll say, hey, Bob, sorry about that. So when we print stuff and we call it, we're replacing message with this argument, which means when we run the function, message is going to equal whatever our argument is, which means when we run the function, message is just going to be hey Bob, which is our argument. And you can go ahead and run this, it'll just print hey Bob. But either way, that's question one, and I believe question two and three as well, because I think it asked about arguments and parameters. So now we're talking about returning. So returning is something that's useful specifically for math. So if you want to do some math, or you want to make it so that your function returns a specific thing when you call it, return is useful. And I'll give you one example with math. So we'll do local function add nums, and then we can return, well, we want to actually set the values when we call it, so let's define some parameters, a and b. And we'll do three. We'll do A, B, C. And remember, you can pass as many parameters as you want. Or sorry, you can set as many parameters as you want. So let's return, sorry, I had to burp, A plus B plus C. So when we call the function and we replace the parameters with our arguments, this is what the function is going to do. It's going to return this here. So when we call add nums and we replace A, B, and C, let's say 2, 4, and 6, this is saying, okay, so we want to replace A, B, and C with 2, 4, and 6, and we want to do this with the function. That's what we want to, that's what we want the function to do. And you can go ahead and run if you want. I'm not going to, but basically it's going to do 2 plus 4 plus 6, which is 12. And that's essentially what return is. It's an effective way to tell your function you want to do a specific thing when you call it. So for instance, I could say local function my text, and then I could say text as my variable, and I'll say return text. And when I set my argument, it's going to be the text. So let's say, hey Bob, and it's going to return whatever the text is, which means we're just returning the argument itself because we're substituting our argument with text for now, right? Because that's just the general form of the function, which is just text, and we're going to return whatever the text is, which means the function is just going to give us whatever text is, and whatever text is depends on the argument that you passed for text when you call the function, which is hey Bob. So this call is going to give me this text. So if I print that, it's just going to print hey Bob, and you'll see here in a moment. So when I run, we just get hey Bob. Sorry, okay, hold up. I did not rename the function, so make sure you're using the name for your function. I just forgot to set it to the new name. So now it knows what function I'm talking about. And then it'll print hey Bob right there. Boom, there we go. Sorry for that. That was kind of sad on my part. But yeah, that's essentially return. So now we're just going to briefly talk about the difference between global scope and local scope. Let's define a local function, func1, and let's define another local function inside of that function called func2. And then we'll say print hey Bob. So, oh, and believe it or not, guys, my name is not Bob, by the way. I don't know where I got the name Bob. I just use Bob for some reason. Like, I don't know where it came from. It's just what I like to use, okay? So if your name's Bob, hey Bob, how's your day going? But either way, the scope of this function, the second function here, is anything that is in the same block of code that func2 is in, which just means is it in the function? So if we call the function, so func1, we still don't really have a way to call func2 because it has a local scope. It's a local function, which means that function is restricted to the block of code that it's in. So if we're outside of this func1, we can't really use func2. But if we're in func1 and we go below func2, so now func2 is defined, and we say func2, we see it actually pops up here because it's in the same, it has the same scope. So if we actually called func1, it would actually run through all of this and it would say, okay, we got another function, and we're going to execute that function. Or sorry, we're going to call that function as a part of func1. So that's actually a third way that you can call a local function within another function. It's just to call the function after you define it. Because calling func1 is going to just run everything here. So if I run, it's going to print hey Bob. And there it is. Local scope just means the data type that you're defining is restricted to the block of code that it's in. Global scope, so any data type that does not have local next to it that you've defined, you can access it anywhere, no matter the block that it might have been defined in. So if I did this, and I got rid of this run that function, we can still call func2 because it has a global scope. But we can't do that when it's local, and you'll see that this func2 will turn red because it's no longer defined because it doesn't have the proper scope for us to be able to call it. So that's essentially what we talked about when it comes to local and global scope. So I hope that made sense. So first question, let's create a function that when called will take 3 inputs, arguments, from 3 corresponding function parameters, and multiply all of them together and print the result in the output. So we're making a function, so let's do local function. And let's name it, well, what are we trying to do? Well, we're trying to multiply all 3 parameters together and then print the result in the output. So let's just say do math. And we need 3 parameters. See, it says 3 corresponding function parameters. And it says we want to multiply all of them together and print the result in the output. So let's say, so we want to multiply all 3 of these parameters together so that when we enter all of the arguments when we call the function, it's just going to multiply whatever those 3 are. So what we do is we do return A times B times C. That's basically what you do. So when we print, this is what the function's going to do when we call it. So when we call it do math, and we substitute for A, B, and C, we can do 2, we can do 8, and 5. So A is 2, B is 8, and C is 5. And when we call, this is what the function's going to do for us. So when we run it should be 2 times 8, which is 16, and 16 times 5, which is 50 plus 30, which is 80. So it should give us 80. And let's see. And we didn't print it. Okay, hold up. See, guys. Oh my goodness. All right. Yep. Whoopsie. Let's print it. And we get 80. There we go. So that is basically the essence of that problem. Pretty easy. Just want to take 3 function parameters and we want 3 arguments that correspond to those parameters. And we want to just multiply all of them together and then print out the result in the output, which we did. So we have 3 arguments, 3 parameters, and we're multiplying all 3 of them together. And when we call the function, we're just going to return this, and that's what the function is going to do when we call it. Sorry, what the function is going to give us when we call it, which is just A times B times C. And whatever we put, we set them as our arguments. All right, so question 2. Create a function that when called will take 1 input from a corresponding function parameter, and the parameter represents the substitute for a brick color you are going to change on a part. So that when you call the function, the argument will be the string representing the brick color you're changing the part to. Okay, so apparently we're trying to change the brick color of a part, so let's insert a part. And the first thing we know is that we need to define that part, so let's do local part1 equals game.workspace.part. So now we've located this part. Let's create a function. So local function change color, because we know we want to change the brick color. And it says it's going to take a 1 argument. So when we call it, or that our argument, from a corresponding function parameter up here, and the parameter represents the substitute for a brick color you are going to change on a part, which is just part 1 in this case. So let's do part color. So that's what this parameter represents. Then let's click enter, so that when you call the function, the argument will be the string representing the brick color you're changing the part to. So let's just say part1.brickColor equals brickColor.new part color, like so. Then let's call the function. So change color, and now we're actually going to pass the argument. So what's the part color? What color do we want to change it to? Let's say really red. Now let's run the game. And there we go. It worked. Okay, so in case you didn't understand that, let's break it down. So basically we define the part, and we want to create a function. It takes 1 input, so 1 argument, from a corresponding function parameter, and the parameter represents the substitute for a brick color you are going to change on a part, so that when you call the function, The argument will be the string representing the brick color you're changing the part to. So this is just the substitute for what we want to change the brick color to. And this is just going to set the brick color equal to this parameter, which when we call the function, we're going to run the function, but this time we're going to have the details that we need to run this code. And it's going to insert really red, because really red is what we replaced with the parameter. And that about wraps up question 2. So hopefully you understood that. Hopefully that made sense. Good job if you figured it out. But let's move on to the last question here. All right, so the last question, question 3, function A is inside another function B. Without using return, what other way can you run whatever's in function A successfully? Well, I'm already thinking there are 2 ways, but let me explain. So function A is inside function B. So let's define function B. Function B, boom. Okay, now we have a function A which is inside function B. So let's do local function A, and now we have function A. And it says, without using return, what way can we run whatever's in function A successfully? So let's just say print blah, 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 blah. And we want to be able to run function A without using return. So we can't say return A. We can't do that. So how do we do it? Well, there's 2 ways. Well, first we need to call function B to run function B. But we still can't run function A because it's local. It has a local scope. So we can't, it's not defined out here. How do we call it? Well, if you remember, there was another way that we could do it, and that's just to call A inside of the function. And that's going to run it. So when we run, we're going to get this print. It's going to work. There we go. We got the text, but there's a second way, which is to get rid of local. So this function is a global function, and it has a wider scope. We can use it wherever we want now. So let's go ahead and just get rid of A here. And now let's try doing A. And there it is, it appears. So now we can run it, even though it's restricted to B, but it's not, because it's global. So even though it's inside of function B, we can still use function A outside of the function. So those are the 2 ways you can call function A without returning the function call for A. Because the third way would just be to return A, which just means you're going to call function A when you call function B. That's essentially what you're going to do. So if we did this, it also does the same thing. But let's redefine it as a local function, and you'll see that when we run, this is the third way that we can run function A. So yeah, that is question B3. So that about does it for the recap. Now we're going to talk about conditional statements. And specifically, we're going to talk about what are called control structures. Control structures are basically statements that control what code gets run. So I want to introduce something fairly straightforward. This is called what's called an if-then-else statement. And basically, if statements control whether code gets to run if a certain condition is met. So let's do this. So let's say local x equals 5. You know what that is. That's just a variable, x, which equals 5. Now let's say if x equals 5. So this is the unique syntax we use when we're going with if statements. And it basically just means if x equals 5. It's the same thing. But we use this unique syntax here where we do double equals. So remember to always use double equals. If you're trying to say that something is equal to something else, you use double equals. So if x equals 5, then, and it's going to open up this end. So basically this block is only going to run if this condition between if and then is met. So is x equal to 5? Well, yes it is. So let's say print x is equal to 5. So let's run. And this should run because x is 5. X is equal to 5. So now, let's set x equal to 3. And let's run again. Let's see. Is it going to run? It didn't. Why not? Well, because the condition was that x equals 5, but x does not equal 5. It equals 3. So this only runs if x is equal to 5. So what if x doesn't equal 5, but we still want to print something? Well, we use what's called else. And else runs if our if statement does not run. So this is basically, okay, well, if this condition isn't met, we're just going to do this. So let's print x does not equal 5. Now let's run. It says x does not equal 5. So let me go over this again. So if this condition is met, then we're going to do whatever's in here. Else, so basically, if this condition is not met, however, we're going to do whatever's between else and end. And that's kind of the gist of it. So you see I have a part here. So I could apply this to basically anything. So let's say this part, let's say I'm trying to see if the part's brick color is a certain color or not, okay? So they say local part1 equals game dot workspace dot part. And I want to say if part1 dot brick color is equal to brick color dot new medium stone gray. So we should be able to, well, I guess not. Well, if it's equal to, if part1 dot brick color is equal to brick color dot new medium stone gray, then whatever is in here is going to run. So let's say print part's color is medium stone gray. Else print part's color is not medium stone gray. So if part1 dot brick color is equal to brick color dot new medium stone gray, which it is, then print part's color is medium stone gray. Else, so if it's not equal to medium stone gray, let's print part's color is not medium stone gray. So let's go ahead and run. And we should get the part's color is medium stone gray. Part's color is medium stone gray. But let's change the part's color to this green here, so lime green. Let's see what happens now when we run. And we get part's color is not medium stone gray. So that's what a conditional statement is in this case here. Now I want to introduce something called else if. So else if basically says, okay, well, if this isn't true, well, let's now check if this is true. So part1, let's say part1 dot brick color is equal to brick color dot new really red. Sorry, really red. Then let's just print part's color is really red. And we'll obviously put an exclamation there. And we'll do else print part's color is neither medium stone gray nor really red. And that's basically what an else if statement. It's an extension that says, okay, well, if and only if this condition is not true, this will run. So this will not run unless this first runs. So if part1 dot brick color is equal to medium stone gray, then we're going to print this. If it's not, we get our else if. So only if this condition is not met, this will run. So if the initial condition is not met, we go down to else if. So else if part1 dot brick color is equal to really red, then print, well, it isn't medium stone gray, but it is really red. So it's going to print part's color is really red. But if it's neither of those, then we're going to go to else. So else is kind of used as, well, if nothing else works, then we're just gonna do this. So let's set the part's color to medium stone gray. I don't remember where it is. Medium stone gray, here it is. Let's run. And it says parts color is medium stone gray. So it worked. So now let's say that it's not medium stone gray, but it is really red. So let's run. We'll see parts color is really red. But let's say that the parts color is neither of those. Let's say it's new yeller. Let's run. Well, now it's going to print parts color is neither medium stone gray nor really red. So that is how conditional statements work. And there are some other things I'm not mentioning yet, but we're going to get into that. So we're going to start back at the basics here. So let's say local x equals 5. Let's say local y equals 10. There are some special words and or. So let's say if x is equal to 5 or y is equal to 2, then print one, at least one condition is true. So that basically means if this condition is true, or if this condition is true, then this will print. So both of them do not have to be true. Only one of them has to be true. If both of them are true, it doesn't matter. It's just going to print. If only one of them is true, it's still going to print. If none of them are true, then it will not print. So if x equals 5 or y equals 2, then this is going to run. So x is 5, y is 10. So one of the conditions is true, so it should run. And we'll get at least one condition is true. So let's go back and let's change x to 1. So if x is 1 or y is 2, then we're going to print this. But if neither of them are true, then this isn't going to run at all. So let's run. And we'll see that nothing prints because neither of the conditions are true. Now, the next word, and, means both conditions have to be true. So if I say and, so if x equals 1 and y equals 2, then we're going to print this. And we're going to change this message to both conditions are met. So would this run? No, because both conditions are not true. X is not equal to 1, it's equal to 5. Y is not equal to 2, it's equal to 10. But let's say that x is equal to 5 and x is equal to, or y is equal to 10. Both conditions are met in this case, so we should see this print. And there we go, both conditions are met. But if even one of them is wrong, so let's say x equals 3, which it isn't, equal to 3, this is not going to run. Because even though y is equal to 10 is true, this isn't. But because we have and, it means that both conditions must be true. If it was or, either or, so one of them has to be true. But if we have and, both of them have to be true. So now I'm just going to basically define all of the different operators. So operators are kind of like the symbols that you use. I'll just explain to you here really quickly. So let's say if x is greater than 5, then print both conditions we'll just say condition is met. Is x greater than 5? No, it's 5. If we did x is greater than or equal to 5, that's true because x is equal to 5. But if we just say it's greater than 5, it's any number that is more than 5. So this is wrong. This is going to run. The next one is less than. So is x less than 5? Well, no, it's equal to 5. If it's less than 5, it's any number below 5. But if we said less than or equal to 5, then yes, it would because x is equal to 5. Then the last symbol I want to show you is not equal to. So not equal to is this little squiggly, it's it's shift and beside number 1 on your keyboard to the left of number 1, that right there, and you should get that squiggly line. and then you'll get equal. So this means not equal to. So if x is not equal to 5, then print. So if it's not equal 5, then this is going to print. But x is 5, so this isn't going to run. Because this is only going to run if x is not equal to 5. But x is 5, so it's not going to run. So those are, like, conditional statements are pretty straightforward. It's not really hard intuitively to understand how conditional statements work. So this is going to be a bit of a shorter episode, but I hope all that makes sense. Go practice. Oh yeah, I said every 5 episodes or so, a couple episodes ago, I said every 5 episodes or so, I'm going to do a quiz covering everything that we did from the previous 5 episodes. But I changed my mind. I think instead what I'm gonna do is every 5 episodes, I'm going to make a project video where basically we're gonna make a game that applies everything that we've learned in the past 5 episodes. I think that's what I'm gonna do instead. Let me know if you guys want me to switch it up. That's what I'm gonna do next episode. I think it'll be interesting. Because to be honest, we just did a quiz last episode, so I think a game is better because it's more. I'm showing you how I would code using the stuff that we learned, so that's a good learning opportunity for you. I think that's overall better for you for learning, so I think that's what we're gonna do. So next episode is going to be a project, and basically we're just going to be applying everything we've learned to make a game. And of course, it'll be a small game. It won't be like a huge game. But either way, I hope you guys enjoyed this video. That's about it for this one. Once again, conditional statements are not that difficult. Pretty straightforward. Go mess around with them for a bit. We'll, of course, deal with them in our project. So I'll be talking about these even past the project. If statement, conditional statements are everywhere. You will see conditional statements everywhere in your scripting journey. So they're such a vital part of coding in general. But either way, that about wraps it up for this one. But until next time, I will see you guys later. Peace.